Hello everyone, and welcome to a little tutorial about mechanical systems, mainly focusing on gears, and we'll start with simple gears, something that we've probably seen in the classroom just recently anyway, so it will be a bit of a refresher, and I'll be able to tell you a bit more about gear ratios and why they're important anyway. Okay, so a simple gear diagram here on the left. You can see the gears actually have some teeth in them, obviously different sizes of gears here, or a smaller one. Usually what we're going to assume here, they say never to assume anything, but we're going to assume this, that the driver is always on the left hand side here, and we'll use that for example. And the driver is usually connected to our motor. There's a wee motor going in, and that's going to be connected up, so that's your driver, and this one isn't connected to the motor, so that's the driven. So that's the actual the picture of what a gear would look like with the teeth, etc. Now normally these would be made out of nylon, which is a plastic. Nylon's quite good because it's self-lubricating. If you made them out of metal, that'd be okay. However, you'd have to make sure there was oil in there, because metal on metal would grind down and it would wear away your teeth, and that's when you get slipping, right? And that's sometimes in your gearbox when your gears start slipping on your car. You can't quite get the right gear. That's because there's wearing down. Now, on this side, you can see the actual engineering symbol for gears. So it's a circle with a smaller circle inside, and it should really be a cross in the middle. So something like that, with a wee inner circle and a wee cross. I suppose my drawing could have been better, but here you go. Okay, and you can see here the driver on the left hand side and the driven. Now it's not always given that the driver would be here, but in our examples we're going to do that just to make it simple, okay? And it just makes it a wee bit easier to just remember that. So let's have a look. So we've got an example here, and I know it says 3A. Where's the other two gone? Who knows? Right, so you've got the driver, only 20 teeth here, and the driven has got 80 teeth. Now our gear ratio is going to be the driven teeth divided by the driver teeth, okay? So 80 divided by 20, as you can see here, that is equal to 4. Makes sense so far, or hope so. Okay, that could be it can also be written as 4 to 1, okay? Because this gear A rotates around 4 times every time gear B rotates around just once. Okay, so 4 to 1. If it was the other way around, it would be 1 to 4. Okay, so driver gear is always, we call that the input gear as well, and the driven gear for this example, we can call it the output gear. Now, if this is connected to our motor, here we are, motor back in, and now we're making much more mess on the slideshow here. So hopefully everyone can still understand this. So we've got it connected to our motor. Now if that input speed is 100 revs per minute, then obviously the output speed, since this is 4 times slower, then the output speed will be 4 times slower as well. So if this is 100 revs here, we're saying that our output speed here at gear B is only 25 revs, 4 times slower. Okay, now see if we can move on here. So there we go. We did a couple of examples here. The example I had here in the class was the gear ratio. We'll just call it GR. I know there's a velocity ratio, but we'll get to that later. Is equal driven over driver. There we go. Okay, that end's still not perfect, is it? It's better not messy. So in this case, it'll be 20 divided by 10, okay, which is equal to 2, or as we'd like to say, 2 to 1, because that driver gear is turning, it's only got 10 teeth, so it's half the amount of that one, so it's turning twice for every time that turns once. Okay, so when we're working out these ones, again, that one would be driven over driver, so 100 for in this case, 100 divided by, oh, there we go, it's a wee bit laggy here, 100 divided by 10, okay, so which is equal to 10, so 10 to 1. So that would have to rotate around 10 times every time that rotates around once. And again, you can probably get the idea now for this one, if it's driven over driver, then you've got 60 divided by 20. So that's 3. So 20 goes into 60 3 times. Therefore, that's going to be a ratio of 3 to 1. There we go. Okay, so the driver gear has to rotate around 3 times every time that one rotates around once. Now, I've always given these 3 examples here with the gears on the driver gears being smaller, but it's not always the case. They could be the large ones, and your output gear could be or the driven gear could be the smaller one. It depends on your system, if you want to speed up the system at the output, or if you want to slow it down. Okay, similar ones here. Look at as I've mentioned, you've got that the other way around, so that will be 10 divided by 50. Okay, which is a fifth, isn't it? Or 1 to 5. So that'll turn around once, whereas that turns around 5 times. So if you wanted to have something that's going round quicker, then you can do that. And again, this is just a 1-to-1. There you are, because they're exactly the same. Okay, so that's the way to work out just a simple gear ratio with 2 gears. Now we're going to build up to including extra gears here to our final gear train. Alright, so what we want to do here is we want to work out the speed of the gear, the driven gear. Okay, so the speed now, since we worked out that it's going around 10 times, every time that's going around once, right, if we say that's 100 revs, 100 divided by our gear ratio, which is 10, or 10 to 1, and it's going to equal 10 revs per minute. Okay, so it's 10 times slower. And in this case, 3 times slower, so 200 divided by 3 will give you your answer for that one as well. Right, which we'll just get in here, which is going to be an odd number here. So our gear ratio is 3 to 1, so 200 divided by that 3. Because we know again it's a bigger gear, so it's going to be slower. So it's going to be something like 66.6 revs per minute. I'll just put revs in here just now. Alright. And the last two, these are the same questions as before, but now we're just working out what this output speed is. There's our input speeds. So our output speeds, in this case, this is going round, it's 1 to 5. So this time it's going to be 5 times quicker, isn't it? So you're going to have that. Since we know that's a smaller gear, that's going to be 5 times faster than the input. So if you can work out 250 times 5, which you should probably be screaming the answer right now. Right, so times 5. Silly me. Right. The reason I'm multiplying it this time is because I know the output gear is going to be faster. And this has no bearing on it, so it's 20 revs in. It's the same gear, so it's going to be 20 revs out. Exactly the same, no change. Okay, because all you're doing, it's a 1-to-1 system. Oh, the wee colon's not working. 1-to-1 system, so there we go. So 20 times 1, 20, or 20 divided by 1, 20. Okay, no change. So here we go. Here's our first task here. So you can pause the video right now and you can try and work out these. What we're looking for just now is the gear ratio. Okay, so like we started at the beginning, whether it was a 1 to 5 or 1 to 10 or 10 to 1, you can work out the gear ratio of each of these. Post your answers on Teams and have a wee check, and then we'll get the answers wrapped up at the end of the lesson here as well. Okay, so hit pause before we move on, and I will carry on with the lesson in a wee minute.